Hello, and welcome to Infinite Expanse Docs. Today, we journey into the silent dangers orbiting our planet. This is space debris, our cosmic trash problem.
Imagine our future in space, not as a limitless frontier, but as a dangerous minefield. What if the very satellites we rely on are silently stalked by invisible bullets? Discover the chilling reality of space debris and why our dreams of exploring the cosmos are literally surrounded by our own trash. Is humanity polluting space faster than we can explore it? A silent, invisible threat is rapidly accumulating above our heads, jeopardizing everything from weather forecasts to national security. Uncover the ticking time bomb of orbital junk and why October 6, 2025 marks a critical moment for addressing this growing cosmic crisis.
Above us, invisible peril circulates. Every defunct satellite, every spent rocket stage, every fragment from collisions drifts through low Earth orbit at astonishing speeds. Once the domain of pristine machinery and exploration, space is now becoming a vast junkyard. Orbiting fragments travel at speeds exceeding 7 kilometers per second. That's enough energy to shred a spacecraft on impact. As our reliance on satellites deepens, so does the risk from these high-velocity hazards. Space agencies and private companies alike are racing to deploy constellations of communication and Earth observation satellites. But each launch, each maneuver, increases the probability of accidental explosion or collision. A single fragmentation event can produce thousands more particles, cascading into what scientists call the Kessler syndrome, a runaway chain reaction of debris collisions. That scenario could render parts of near-Earth orbit unusable for decades. Our story begins with humankind's first forays into space. The Soviet Union launched Sputnik in 1957. In subsequent decades, almost every mission left behind some vestige: rocket bodies, abandoned instrumentation, shrapnel from micrometeorite impacts, or even flecks of paint. Over time, they accumulated into a swirling cloud of hazardous fragments. Today, more than 34,000 tracked objects larger than 10 centimeters orbit Earth, and countless millions between 1 and 10 centimeters hurtle unseen. Though tiny, those medium-sized particles carry devastating energy. Collisions with such debris can disable satellites, jeopardize human life aboard spacecraft, or damage crucial infrastructure. The International Space Station must constantly maneuver to dodge predicted debris paths. Astronauts walk under threat. One strike to an astronaut suit or module could be catastrophic. Compounding the issue, debris is extremely hard to clean. Tiny fragments don't follow predictable orbits for long, and there is no natural mechanism to remove them quickly. Proposals abound: nets, harpoons, robotic arms, ion beam shepherds, lasers, each with promise, but also substantial technical, legal, and financial challenges. To succeed, such systems must operate at high altitudes, against orbital velocities, and navigate complex international regulations about salvaging or destroying objects in space. One novel idea uses drag sails or plasma tethers that increase atmospheric drag at high altitude, slowly deorbiting derelict satellites. Others explore ground-based lasers to nudge debris into safe decay paths. Meanwhile, engineers design future satellites to minimize creation of new debris by using safer propulsion, controlled re-entry, and end-of-life disposal plans. Still, those solutions must scale to match the pace of satellite deployment. International cooperation is vital. Treaties and guidelines exist, such as the Outer Space Treaty and the UN's Space Debris Mitigation Guidelines, but they lack enforcement mechanisms. As more nations and private enterprises launch into orbit, each must commit to responsible behavior and invest in debris removal or mitigation. Space is a shared commons. Leaving it polluted imperils all.